Hello, and welcome back to CODE&CLOUD, the podcast where we explore the intersection of technology and strategy for modern digital projects. I'm Rauno, and today I'm proud to host Beyond the Cloud Wars, a pragmatist guide to multi-cloud architecture. The narrative of the cloud wars often pits providers against each other, but the reality is that for many organizations, there is an hybrid multi-cloud landscape. How do you navigate this complex ecosystem to build solutions that are effective, resilient, and cost-efficient? I am very happy today to host a seasonal solution architect who is also a very old friend of mine, who brings years of experience from across major cloud provider and the foundational world of managed hosting. Alex Moore, AI Infrastructure Customer Engineer EMEA at Google Cloud.
Hi.
Hi, Alex, and thanks for accepting our invite. Welcome to CODE&CLOUD. We know each other since quite some time. I think it was 2001, the first time we met each other. But do you want to say a few words to present yourself to our audience?
Sure. Yeah. Thanks, Rauno. And yeah, great to be collaborating again. So yeah, I'll paint a bit of a brief picture of my background. And yeah, it's been close to 25 years now working in the infrastructure space. And yeah, starting way back at the turn of the millennium when we first collaborated. That was with a hosting company called Verio, that was really born out of the consolidation of hosting companies emerging from the dot-com boom and then bust. And they were acquired by a Japanese telecommunications giant, NTT, where I spent many years with them developing hosting solutions that evolved into cloud solutions. And then probably around 10 years ago now, I think, kind of pivoted to focus more on the hyperscaler world, starting out with a Microsoft consultancy in the UK, building out an Azure managed service capability, and then onto a multi-cloud managed services company based out of Spain, forming part of their founding team as they expanded into the UK. But then for the last almost 5 years now, I've been with Google Cloud within our customer engineering team. And customer engineering is really here to make customers be as successful as possible with Google's broad technology stack. And again, my focus has been on all of the core infrastructure, so compute, storage, networking, projects like large data center consolidations or high performance compute kind of workloads. But I've recently pivoted in the last few months to focus on what we call AI infrastructure. So that's helping customers with like large scale AI training and inference workloads on Google Cloud, tackling like a range of really super interesting challenges that emerge when you scale these massive models on these platforms. And yeah, I should add that I'm speaking today purely in a personal capacity. I'm not here talking on behalf of Google or Alphabet.
No, that's clear. And today I am really here not to interview the Google Cloud engineer. Obviously, exciting to talk with someone at a giant and hyperscaler as Google Cloud. But the reason you're here, we know each other a lot, and you express it very well by explaining your career and your experience, is the fact that I really like to get your personal view that comes from your extensive experience across multiple vendors in multiple mission critical projects, starting from what was a traditional enterprise architecture, managed hosting solution, consolidation of the hosting farms to the different work on the different hyperscaler to the most innovative cloud solution that you have mentioned. You witness the industry evolution, in fact, from the managed hosting to the hyperscaler era. And so looking at this, at your career, the experience you made, how has this journey changed the fundamental principle of designing resilient and scalable system? What's one core lesson from the old world of the hosting that at the time that we met, let's say, that you find is still incredibly relevant, or perhaps is dangerously forgotten in today's cloud native landscape?
That's good questions. And yeah, like if I look back at Verio, as I mentioned, when we first started working together in what was called enterprise hosting. And enterprise hosting was really any kind of hosting that had more than one server, basically. Because back then you had plenty of web server type hosting companies, but it was quite rare for people to be doing anything largely complex. And 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 back then the web was still very new, and the concept of running IT workloads outside your own comms room or data center was actually pretty unheard of, particularly in the enterprise. And there were co-location facilities, of course, back then, but the idea of handing over the keys to the infrastructure to someone else was pretty novel, if really not even existent, apart from maybe for some bleeding edge web-driven companies. And it wasn't called cloud, and it wasn't really cloud at that point. I think people often say, the whole cloud is someone else's computer, which hosting is, but it didn't have APIs back then, didn't have a lot of the automation that customers have kind of come to learn on cloud. I think internally we had a lot of automation, but we didn't expose any of that to customers like it is today. And I think it also largely consisted of like a handful of quite base building blocks, right? So servers, maybe some kind of storage platforms. Maybe if you're super advanced, you'd have a load balancer, but it would be a physical load balancer, like a network switching device, not the software-based load balancers we kind of see today. And commercially too, like it was quite different, right? Customers would subscribe to a fixed term contract with well-defined services. And so the solutions were very static. You kind of built for your peak demand, you built for the disasters that you may or expect, or maybe you don't build for disaster scenarios. And so it was largely static from an infrastructure standpoint. But cloud kind of really addressed both the two limitations at the core. It introduced an API sort of framework for driving automation, and it also introduced this flexible pay-as-you-go commercial models, right? So suddenly you can self-service deploy infrastructure, use it however long you need, remove it again when you're finished with it, and only get billed for what you use. And that was really revolutionary, really, at the time. And of course, it's built up from there. We've added layers of native automation, new platforms for data processing and storage, and now, of course, AI services, all at a touch of a button. And architecturally, I think the key thing that changed was flexibility. You no longer kind of needed to build or even pay for that kind of peak demand, but you deploy solutions that auto-scale based on usage. You can deploy new solutions on demand and experiment much more than you were able to in the past. Now, obviously, that has impact architecturally on the software stack as well, right? If you want an application that's going to dynamically scale up and scale down, it needs to be able to behave appropriately and not store state on machines that are going to disappear if they in the next minute. And so it does have an impact from that standpoint, but it dramatically kind of improves the ability for people to consume, like literally on demand, the infrastructure that they need at that point in time. And I think that's the big thing that's kind of changed the most over the last kind of 20 plus years. I think if there was like one thing in the old world that's still very relevant today, it's got to be DNS ultimately. I mean, the joke of like any outage is that it's always DNS, and that's still very much the case today. Like it's at the fundamentals of communication on modern applications is ensuring that you can kind of look up services and connect to services. And it's surprising even today the number of times you encounter some kind of operational issue or challenge on a customer environment and it's something to do with DNS. It can't be overstated how important those fundamentals are. Even with all of this machinery that you have at your disposal, you've got to make sure that those fundamentals are in place.
The DNS is always something that surprised me also today when I do a project. You mentioned one word that for me is quite a keyword when you talk about cloud, that is the API and self-service model. And then very often it happens that you do your project, you have your full automation for provisioning it and scaling and fixing. But then everything is stopped because for the DNS name registration, you have to fill a ticket to a department of the company where someone sitting on a desk will have to take care of that, because it's completely possible to fully automate also that part, but people don't trust doing that.
Exactly. And I think also from a system standpoint, all of the cloud providers have really robust DNS services as part of their fabric. And it surprises me the number of enterprises who, try and re-implement it, right? They want to run some kind of their own DNS solution on top, and that ends up becoming quite often a bottleneck for some reason, or it's down and therefore it's causing outages to an application stack. And And yeah, that continues to sort of surprise me. They should be leveraging these kind of native services which have been engineered at scale, and those are solved problems, but some people like to make sure that they solve the problems, but not always necessarily effectively, which is kind of interesting.
Yeah, that's always interesting, but it's true, the baseline things are still relevant, and on the other side, it's true that sometimes the self-service model of the cloud is leaving people to forget that part, or doing things without knowing how this fundamental part are still required in order to do things.
Yeah, exactly.
Talking about cloud, I was telling in the introduction, I mean, we have different cloud providers. We have each cloud provider that is rich in terms of services that we can fulfill all your needs in a cloud provider. But there is this multi-cloud strategy that is often mentioned by consultants, but also by different companies. And the most common reason that is mentioned when you talk about multi-cloud strategy is to avoid the vendor lock-in. From your experience, for your on-the-ground experience, is that a real driver for a multi-cloud strategy? And what are the more practical business-driven scenario where a multi-cloud architecture is generally the best choice, and when is it just adding instead unnecessary complexity to the platform, to the solution?
Yeah, it's a good question. I'd say a lot of enterprises, especially larger enterprises, kind of fall into a multi-cloud scenario for all sorts of reasons, right? They might have different business units or departments that have forged their own way to build out some kind of technology platform on one provider, and then another team does it on a different provider. Or mergers and acquisitions is another one, right? That you acquire some business that is running on a different provider, and before you know it, you've got a multi-cloud scenario that you're now responsible for. And so that kind of M&A piece, or that kind of maybe, I don't want to say shadow IT, but like especially in large organizations, just different parts of the business operating independently can cause you to sort of fall into a multi-cloud scenario as opposed to a strategic decision. There are definitely some business, particularly in regulated sectors, where business continuity is important, and concentration risk with a single provider. So they're looking at it from a risk mitigation standpoint. It's not necessarily around technology lock-in per se, but it's around supplier, like I say, concentration, and looking to diversify that, and therefore risk mitigate any kind of issues with a particular provider. I would say that there can be cases, but it's rare, but there can be cases where there may be some particularly specialized service. But more often, actually, it's more potentially around regional deployments. So there can be differences, particularly between some of the major hyperscalers, where they're in one region versus another one is not in that region. And you've got a business with that might have, data residency or sovereignty requirements to store data in that particular country, and that would drive you to use a provider that operates in that region. That can be a real tangible driver. The service piece, like, do they have technologies and services? It's a harder one because, all of these providers, particularly the larger hyperscalers, are all, constantly, keeping up with each other. And so the level of differentiation on some of these services tends to not always be as clear, right? A virtual machine, is a virtual machine. However, that does start to change when you start using some of their higher level, what I'd say more value added services, right? The more platforms as a service. So on the Google side, for example, we've got a great AI solution called Vertex. And that's unique to Google, right? It brings a lot of machinery for enabling AI solutions. And there are other similar solutions in other providers, but they do have material differences in how they operate and how they integrate in the, in the AI kind of ML ops, for example, life cycles. And there may be then like almost preferences that come from the types of teams within a business to gravitate to one particular solution. And actually even more so in the AI world is then the AI models themselves, right? That they are very unique intellectual property owned by the different providers. and there may be a model that's servicing a particular use case. It's just only available from one particular provider, which might drive you kind of one way or another. So there are some kind of specific use cases from a service standpoint, but at the kind of, if you like, the lower down kind of IT infrastructure level, it really comes down to things like that risk mitigation, or the fact that you've just naturally acquired multiple services, or that you're trying to, especially at a larger enterprise, actually, you're trying to service, like provide choice to your business. So I think that's another thing that you want to be able to, like I say, especially for the larger multinational type businesses, the IT department is a business enabler, right? And so as part of that is providing access to a broad portfolio of service, which may include multiple cloud providers. And as part of doing that, rather than being on the back foot in terms of enabling those providers and sort of suddenly having to integrate them, if they proactively make a decision to say, actually, we are going to support 1, 2, 3, 4, whatever number of providers that they choose, and then make sure that all of the foundational pieces are in place around them, so they're not caught out, right, around identity and access management and governance, then they can much more confidently kind of do it, make available a multi-cloud scenario in a controlled way to their broader enterprise.
Yes, that's the way to try to fight the shadow IT that you mentioned before. So you could get multi-cloud without even maybe knowing it because of the shadow IT, or you can try to avoid shadow IT by enabling directly the multi-cloud to your internal consumer.
Yeah.
Because you know that they will do it, so at least they will do it in a controlled way.
Yeah, exactly. And I think one of the other things is that you kind of have to go in eyes open, right? The clouds are different. I think there's a lot of people, like I mentioned, there's a lot of similarity in what the type of service they're offering is there. A VM is a VM is a VM, but the way they implement it, the way they offer it, the guardrails and controls they put around it is different between all of them. And so there's an inherent risk, if you like, to then opening up an additional provider, because suddenly you're going to have to become aware of all of the controls that you need to put in place to govern and operate that in a safe and secure manner. And that introduces complexity that may be unwarranted or not needed, right? There's sort of a value discussion there is the value of us going into a multi-cloud scenario worth the effort that it's going to take to integrate that additional provider? So yeah, it's interesting.
That brings to exactly to the next question I wanted to ask you. So when you mix services from different providers, so you're using Google Cloud, BigQuery, or Vertex that you mentioned before, or the AI Studio for the data analytics, while your main application runs on another cloud or on premises, etc. What are the hidden challenges? I mean, you were already mentioning some of them now at the end of your previous answer. Can you walk us through the non-obvious hurdles in area like the data egress cost or security and identity management, network latency, but also things related, you mentioned the regional aspect, the sovereignty things. So all this complexity that an architect must solve if a multi-cloud platform or a multi-cloud strategy is something that this architect has to support and has to sustain.
Yeah, I mean, like I say, we've touched on a few, and I think at the core of some of it is data, right? A lot of these things, ultimately, all IT is around data, right? We're processing data in some way. We're taking data in, we're processing it, we're sending data out. And this term data gravity has been around for quite some time now, and it's very real, right? Moving data, it takes time, it has cost, it potentially delays processing because of latency and things like that. So understanding, like, architecturally where your data sits and how it's going to be processed by different components, wherever they might sit, is kind of the number one thing you need to think about kind of architecturally. And yeah, when you're in a multi-cloud scenario, data movement can have a very real cost in many scenarios. Now, funnily enough, at Google, that we've introduced some services, particularly for EMEA customers, whereby if you're on a multi-cloud in a multi-cloud scenario, there's actually you can register another provider, and have your egress costs removed specifically to accommodate that kind of multi-cloud scenario. But like I say, it's not just a cost thing. It's also like, how long does it take that data to move from A to B? How frequently is that data changing? And so what volume of data do you need to move? And how quickly does it move across? Because that might have a material impact to the application, right? So, particularly if you're trying to, and I wouldn't typically encourage it, but if you're trying to split an application across multiple clouds, and suddenly you've got some kind of client access on one cloud that's kind of having to go across and do something in another cloud environment, that introduces a lot of complexity architecturally. You're dependent on kind of data movement, network access, two different providers. And so, yeah, you can have a lot of complexity introduced as a result of that, that can materially impact the end user, right? And the end user is king in most cases, right? You want to make sure that they're getting a good, timely response to whatever application or process that they're trying to execute. So yeah, the cost and movement of data is definitely, for me, kind of the number one factor. I think the other one is around like security and governance and compliance. They do have different identity platforms, and there are mechanisms to integrate them, right? There's a lot of federated identity capability across all the providers these days, but that adds a layer of complexity that you need to get right, because identity and access management is critical from a security standpoint. And so it can lead to kind of fragmented approach to governance, maybe challenges around compliance, different levels of compliance capability on different providers. There's definitely a lot of things to think about from a security, governance, and identity kind of standpoint. So I sort of think these are the two main ones that I would sort of focus on. Is that piece around the identity, and then the storage and data movement piece, right? Those are the key ones.
Yeah, and for sure, you get latency, you get additional traffic, you can get also additional cost of duplicating data between the different locations. So on one side, I think it's different approach if you consider, and maybe we come to that later, but if you consider a multi-cloud approach in terms of disaster recovery scenario. So I want to be sure that I can turn on my services and run my service and get my data, even if the cloud provider has a regional disaster and then the cloud is unavailable, and I can run it on another cloud or get the data in another cloud, even if maybe you can even just only select a new region of the same cloud, because that would be a major global disaster not to be able to use different region of the same cloud. But to run in actively in a multiple cloud, you are moving your data and duplicating your data in two clouds. And as you were mentioning, you will need to manage compliancy on the data management in two different way of doing it. So it's adding an enormous complexity also from I would expect not only from an IT perspective, that is what we know more, but also from a legal perspective, probably.
Definitely. And I think the other thing, particularly when you're trying to, it's interesting as well around disaster recovery, when one of the challenges that it introduces is that you start to restrict yourself to the baseline lowest common denominator of service, if you like. Like a VM here and a VM there, or maybe a container there and container there. And some of those services, even as you go up the stack, still have some levels of compatibility. If you take Kubernetes, for example, right, you have GKE on Google, but you also have AKS and EKS. But the providers all then provide native integration for things like load balancing, and they behave very slightly differently between them. So it's not necessarily just a case of applying your YAML in one location and suddenly it all works. So there's a lot of kind of due diligence almost to make sure that if you are going to do that, then you know that it works, right? You've got to test these things, but also you sort of lock yourself out of being able to take advantage of a higher level, higher value services, right? Where there can be where the real cloud value starts to come from some of the serverless platforms, for example, which tend to be quite different between the different providers. You can't necessarily have a serverless solution on one that's identical on the other. You can recreate it, but it's not like you can just apply the same Terraform, for example. It's going to be different.
Yeah, that's the point we get often also when we talk with other people in the tech area, when it comes to me to do some training session. I mean, Terraform is multi-cloud, is cloud agnostic, but it's cloud agnostic as an engine to apply infrastructure as code. But your actual infrastructure definition is not the same between the different cloud. Each cloud provider has its own API with different attributes, with different workflow. So you cannot just create a Kubernetes cluster in one cloud the same way you create in the other cloud. It will be similar. There will be something that is similar, but will not be the same thing.
Yeah, exactly. Yeah, it's interesting.
Yeah. As a solution architect at Google, you have a very deep knowledge of your platform. But thinking about your multi-cloud background, your experience on different solution, and also your solution architect experience, how do you advise a client on choosing a specific service? What's your mental model for deciding with a specific tool, I don't know, Spanner or certain API, AI or ML service, or a Google Kubernetes engine, or any specific service is so compelling that it justifies the integration effort in a non-Google environment, or selecting a service in one cloud because it's perfectly fit for the job while all the other workload are on another cloud, or maybe not? I mean, what it's your suggestion on the design in the solution? There are reasons to do that, or maybe there are more cons than pro, and so it's still better to avoid the mix if it's not strictly needed.
Yeah, it's a good question. I think because of some of the things we've already talked about, to be honest, that the default would be to try and minimize that. And I'm not just saying that as someone who works for Google to say, yeah, you should come to Google exclusively. Of course, we'd like that. But like because of the things you talked around data movement, compliance, governance, management, skill set even, right, that it introduces an order of magnitude of complexity as soon as you go into that multi-cloud scenario. And so the reason to do it has to be real. Now, there are passive reasons that we talked about, right, that just through M&A, you end up in a multi-cloud scenario, or different departments in a multi-cloud scenario. But to proactively design for a multi-cloud use case, unless it's driven through some kind of compliance need around a multi-sourcing vendor strategy, there'd have to be real compelling business drivers, ultimately, that there's some value from a service in another provider that cannot be obtained from anywhere else, or at least not without significant investment, for example, that drives a need to kind of create that complexity, potentially. I think that, that's, it all depends, right? It depends on the scenario, depends on the application. And actually, for your common garden, your regular everyday workloads, the decision is normally to try and steer to keep those in one place, right? Because you're going to minimize some of those issues of data movement and latency and cost and things like that. But there's always that kind of like 80-20 rule, I guess, in the sense of, can I achieve like 80% of what, is it good enough, basically, or do I need to kind of get to that extra specialized service that's unique? And in the API world as well. So I think from an infrastructure standpoint, because this is the other thing, I'm talking about it from a pure infra standpoint, and like moving virtual machines and moving workloads, moving storage, all of those things, that is, like I say, brings with it a lot of complexity and problems. But actually, if you're just calling an API to take advantage of some nice, clean, decoupled service, then actually maybe that also isn't a problem, right? I mean, maybe there are definitely use cases if you're going to just take advantage of a very discrete service with a very clean interface, with minimal external dependencies. You're just calling an endpoint with some data and it's giving you a result back. Then that can be definitely a mechanism for like multi-cloud integration. But I think always, I wouldn't rush into it, I guess, is my answer, because you're definitely going to enter into a range of different sort of complexity that you're going to have to deal with.
Yeah, complexity is. I think it's a key word on this. Complexity means something that you need to study to get information around it, to try to manage. In the previous episode, in episode 5, we focused on the developer daily reality, and we were talking also about the cognitive load that is impacting the team. A multi-cloud strategy, as we were mentioning before, is it's having a direct impact on that daily reality, forcing the team to understand multiple ecosystem, to understand the multiple services, the way they are doing the same things that is slightly different or doing different into the different clouds. So in this context, keeping the point you were mentioning before, that we'll come back at the wrap up, because I think it's an important lesson learned for today, that multi-cloud is not mandatory. You really need to have a use case for that, or a business case for that. But if we get a company that fall into a multi-cloud solution, what is the advice you could give to the leader of a company like that on structuring the team, managing the cognitive load, and so creating something that is a bit easier for the developers, so they can still be productive without needing to be expert in each and every of the cloud platform?
Yeah, it's a good point. I mean, the pace of change. There's sort of two things, right? So there's the pace of change of the platforms, and then there's the platform itself. You know, we've already talked about how they each bring with them their own unique kind of mechanisms for identity and access management and governance and policy management, etc. So you have to have teams that understand, either as a single team, understand each environment and their differences, or maybe separate teams that can address the unique requirements of each provider. But also the pace of change, right? The crazy level of like feature enhancements and new developments and new best practices that are happening literally on a daily basis from all of these providers. It's, you know, I work in one provider. It's difficult enough for us, and I actually work specifically on infrastructure, and it's hard enough for me to keep up on that narrow segment, if you like, of a set of products in that space in one provider, let alone doing that across multiple providers. And all of that, like you say, brings like huge levels of cognitive load. I think like one of the things in terms of, it depends a bit on the size of the business, right? You know, a small business, I mean, arguably whether they would have multiple cloud or not, but like they're going to, you know, they'll probably swallow that complexity into one team, right? They'll just have to deal with it, even though it's going to be a huge challenge and stress on the team. But larger businesses, you'll probably abstract that. And the way you'd probably do that, the term that floats around these days is like platform engineering, right? You'd establish some kind of centralized team that are responsible for the platform, maybe layering on some kind of sort of application delivery or software delivery abstraction layer, or set of standards and tools for deployment and development of applications on that platform, to make it almost agnostic from the business, right, in some way. So that you know, it could be something as simple as like, all right, I've got to deploy this container, and I just pick AWS, or I pick Google, or I pick Azure. But then it may be even not even exposed to them, right? That they just say, I need to deploy this workload, and the business takes care of shifting that to whichever provider makes the most sense. And what that means is that then the development teams, the application teams, are abstracted away from that complexity. They're reassured that they're deploying into a well-controlled, secure, governed, managed environment with a set of guardrails around it. And they don't have to worry about that. They can just focus on adding value in the application stack that they're developing and building for the organization. You don't escape it completely, right? The platform engineering team probably themselves are still wrestling with all of the nuances between these providers. And again, depending on the size of the team, there might be one team who is just multi-skilled across multiple providers, or you might subdivide down and have like a team for each. But you're probably then going to need some kind of like overlay governance layer that is defining policy, right? So you might have a baseline set of principles around identity and access management and governance and compliance that your company is adhering to, defining and agreeing that at an organization level, and then having to map that into how you would fulfill those requirements with each provider. And then that might be executed by a separate team, right? You might have a Google team and an Amazon team and a Microsoft team, for example. But a lot of that is going to be just dependent on, again, size and complexity of both the business itself, but also the number of workloads you have, and etc. Yeah, it depends, I guess, is the consulting kind of answer. But yeah, I think trying to like help people abstract away some of that complexity, and where appropriate, have dedicated roles focused on a single provider. But you do at the same time, you want to make sure that there is that consistency, I'd say is probably the right word, between them, and where appropriate, where feasible as well, right? Not always 100% feasible, but
yeah. So I'll try to take some keywords so that we can try to wrap up the discussion. So I took notes where you were talking about some of the words you were saying. So try to put them together. So I'll leave you then the sentence, a couple of sentences to try to wrap up this discussion. So what I got from this discussion was really interesting and enlightening to me when it was putting the attention to certain words, and what's really this way. I thank you for this conversation, was really pragmatic and realistic, because there's a lot of, let's say, also marketing password related to hybrid and multi-cloud everywhere. I think what you were saying, I mean, the key points that I took is we can get multi-cloud very often not due to strategy, but because of merchant acquisition, or because decision taken by multiple teams, often due to a shadow IT approach. So the single team that decide their own cloud without coordinating this internally, or sometimes it can be the internal IT department that, to avoid the shadow IT approach, start to propose multiple cloud. But it's not, if not in certain really high-end solution, is not usually that fight against vendor lock-in. Also because if you want really to avoid vendor lock-in, what you were mentioning, that I agree with you, you would need to stay very low level in an infrastructure as a service model, where you are also losing many of the benefits of running on cloud if you stay there. There are regional considerations that are also important for the cloud selection. So not only the service, but also in which region the cloud is present, which compliance they need to match. Everything is about data, and moving and processing data is very relevant in taking any decision, and in data duplication, cost, but again, security and compliance on managing the data. Multi-cloud is on high level complexity work, especially if we talk about infrastructure as a service or platform as a service. But you were mentioning before, taking this point that was interesting enough, that is, if we consider the software as a service offering from the cloud provider, then a multi-cloud approach could be probably more easy to be engaged with, because you have some API that you call for a specific service. You don't have to integrate an entire platform. And finally, to then leave you to talk for the wrap up, to correctly manage the multi-cloud approach, no matter what is the source of this reality in your company, you need to do it if you have the size and the capacity to manage that, because it adds additional cognitive load. And the platform engineering approach, so to having a platform engineering team separate from an application development team, is a way to try to manage this. And obviously this means that a multi-cloud approach is something that is sustainable for a company that is big enough to have this split. I mean, if you are a startup and you have your team of 10 developers, why you should go to a multi-cloud? Select one cloud and try to get the best out of it, because you would not be able to keep the pace of the innovation of all the clouds and follow what they are doing. These are the things I kept from your discussion. So I'll leave you for a couple of sentences to wrap up your discussion. If I say something right, or I got it wrong what you were meant to be.
Yeah, I think you've you've done an amazing. You're like a human large language model, like summarizing a long conversation. Yeah, no, I think you kind of nailed it there. I think yeah, there are a lot of dynamics when it comes to multi-cloud, and it's definitely a viable architecture in some scenarios, and there are a lot of tools out there. I mean, the one thing we didn't talk about actually is tools to facilitate it, right? You know, a lot of providers, including Google, have services that can manage and provide some of that operational governance, you know, across, whether it be from a security standpoint or, you know, Kubernetes governance, for example. You know, there are platforms that Google has, and I know other providers do as well, that allow you to provide an integrated view in a multi-cloud scenario. But yeah, it's definitely something that, you know, is needed in cases, but proceed with caution, I would say sometimes, and just be aware of some of those complexities that it can introduce.
No, thanks a lot for your words on this topic, and especially for having moved this topic away from the buzzword and marketing thing. So yeah, we all need to be multi-cloud and try to make it really realistic. So there can be cases where we have advantages on being multi-cloud, or there are cases where we can't avoid of being multi-cloud, merge and acquisition, the multiple team, etc. But the reality from a solution architect and or operation manager point of view is that multi-cloud is not strictly needed in all the cases, and you can have high availability and scalability in the single cloud due to the multi-region, multi-zone, multi-region approach. Your correct planning in terms of capacity, and you can avoid the additional load, the additional complexity of every multi-cloud that you will have not to underestimate. Many tools, as you were mentioning, can help on that. You can abstract things, etc., but still abstracting things as a cost. So you need to consider. So multi-cloud does not come for free, and you really need to have a business case that justify that additional cost, that is cognitive cost, time and effort, but it's also money at the end for the business.
Exactly.
Okay, so thanks again to Alex, and thanks everyone for listening to CODE&CLOUD today. The conversation doesn't stop here, so join us on our social account to share your thoughts on today's topic. It's really useful for us to get any feedback so that we know if we are moving into the right direction, if the topics are interesting for you, the format, and we can improve the way we mention this podcast. If you enjoyed the show, please subscribe, leave us a review. Really helps also others to find us. And be sure to follow us so you don't miss our next episode. We will talk about connecting cloud technology to the business value with Luca Giura-Trabocchetta, equity partner at Deloitte. And until next time, keep your code clean and your cloud scalable. And as we used to say at Newesis, be professional and have fun. See you next time.